Good morning, students. So in the last class we have studied about some important concepts of alternating current. So moving on, without wasting much time, we have studied about instantaneous voltage, current, peak voltage, peak current, and so many things we have studied. So the most important fact we studied in the last class was phase. So about phase we have discussed in detail. So as I told you in the last class, today I am going to discuss about one more important thing, or you can also say it as an important parameter related to alternating current, that is phase difference. Means, you know, when you think about alternating word, there you are related to two quantities, means that is alternating voltage and alternating current. To this we can also call as instantaneous voltage and instantaneous current. So here, related to these two factors or related to these two characteristics of alternating current, we are supposed to discuss about phase difference. Means how the phase of these two quantities are changing with respect to each other. Okay, so for that what I will do, I will consider two waves. One is showing alternating voltage and another is showing alternating current. Okay, consider two waves. So let this be a wave A, means this is a solid line. It represents the waveform A and it represents the alternating voltage. And one more wave I will consider, that is dotted line. I will consider one dotted line, and let's consider this as wave B, and this wave B represents alternating current. Okay, so these two waves are moving with the same period. The important thing is what? Same period. The wave A and wave B are moving or propagating with the same period. Means whatever the properties, period, frequency, amplitude, whatever it may be, they may be with respect to same. They are same with respect to A and same with respect to B. So this wave A and B are moving in the same period. So what will be the phase difference? The phase difference is the property of difference between the phases of two waves moving in a same period. This is the difference in phases of two waves moving in a same period. Okay, so how we can analyze the phase difference with respect to two waves means, I will show you the two diagrams. So this may be the first one. So as you know, one wave is A. Okay, this is wave A and it is representing what? Alternating voltage, or also you can consider instantaneous voltage here. Okay, so the one more wave which is wave B, and that is also represented in the same diagram like this. See here. So this dotted line represents what? This represents the instantaneous current. So this solid line, wave A represents instantaneous voltage, and dotted line, wave B represents instantaneous current. So when these two waves are moving in a same period, now you think of their time and radian. You know what will be the time period T and radian is pi, that we have studied in the concept of phase already. So here you think of the time of wave A here. This is wave A which is representing V0. The time of wave A is 0 here. Okay, so what it will be here? So at this point it will be T by 4. You know it already. Here it will be T by 2. Here it will be 3T by 4. And here it will be T. This is what? The time period with respect to the wave A. Okay, same, you start off thinking the wave B. So what will be the wave B at this point? Same, 0. Here it will be T by 4. Here it will be T by 2. Here it is 3T by 4 and here it is T. And also think of the radians. Here it is pi for both the waves. Means for A and B the radian is pi. Means 0 it is. here it is pi by 2, means this much phase is covered, pi by 2 is covered. So at this point both the waves are showing the radian pi by 2. So here both the waves are showing the radian pi. Here 3 pi by 2 and here 2 pi. Means when you consider these peak points and the middle points, the time and the radian are same. Means there is no difference. So such waves are said to be in phase. These waves are said to be what? In phase. Means there is no any phase difference between them. Means see here, this wave A has covered a distance of pi by 2. Means it is covered a phase of pi by 2. The same way B is also covered the phase of pi by 2. Means there is no difference. They are in the same phase. Hence it is in phase. Such waves are called as what? In phase, and the phase difference between these two waves is said to be 0. Understood? So this is what? First type. First type, that is what? In phase. I told you what is the phase difference? It is the difference of phase between two waves or two alternating quantities. Alternating quantities means that may be alternating voltage and alternating current. So it is the difference of phase between two alternating quantities moving in a same period. Understood? This is the phase difference, and this is the first type of phase difference. That is when the two alternating quantities are in phase. Means the instantaneous voltage and instantaneous current are in phase. This is the first part. Then what will be the next one? Means here in this case there is no any phase difference existed. So what will be in the next one? So the next, the same two waves I am considering, means instantaneous voltage and instantaneous current, and the solid line represents voltage, dotted line represents current, but there is some difference. How means? See, the first wave A is same. First wave A is same as it is, and it is representing voltage, as you know. Okay. Now the wave B, the wave which represents current, that will be somewhat like, see here. Okay, so the initial diagram which I have drawn and this are slightly different. Slightly difference means meaning is lot of differences are there. But see here, the first wave A is traveling like this. Its position is 0, and here its position is T by 4, T by 2, 3T by 4 and T. Okay, now what will be the wave B? What will be the wave current? See here, it started from T by 4 already. So here it is T by 4. For the wave B, it is already at T by 4. So now you come here, what it becomes here? T by 2. So here it is T by 2. T by 4 distance is covered. One more. Here it is 3T by 4. And here it is T. Understood? The wave B started its propagation from T by 4 itself. So when it is at T by 4, it comes like this at T by 2. It comes like at the reverse peak 3T by 4 and it reaches the equilibrium T. Okay. So you know what is the propagation of wave and what is the propagation of B. Now you think of comparing both of them. Compare wave A with wave B. So what happens? The wave A is at 0 when wave B is already at T by 4. Okay. So when wave A is at T by 4, the wave B is already at T by 2. Wave A is at 3T by, it is at T by 2. The wave B is at 3T by 4. Means they are not same. Initially, the previous one diagram, when it is at 0, B is also at 0. When it is at T by 4, B is also at T by 4. But here, they are not at all same. Means their equivalent positions are not same, they are changing. So when you think of this point, the wave B is showing T by 4 and wave A is showing 0 position of time. So you can think of the phase difference between A minus B or B minus A, T minus 4 divided by 0, that is T by 4. Means B has already reached the point T by 4 when A is still at 0. So you can subtract. Phase difference is there. No, difference is nothing but what? Subtraction. So T minus 4 divided by 0. So at this point we have got the phase difference T by 4. Okay, come to the next point. See here, A has started its travelling and it is reached the point T by 4. But B has already completed half cycle. So it is reached at T by 4, means T by 2. So the equivalent positions of A and B shows again phase difference. How? T minus 2 minus T by 4. So again it is T by 4. Come here. It is at the second peak. It is at the reverse peak. P is at the reverse peak. But A had just completed half cycle. So it is T by 2. It is 3T by 4. 3T by 4 minus T by 2. Again T by 4. So throughout every point, throughout every phase in this diagram, we are getting a phase difference of T by 4. Means both the quantities, both the alternating quantities V and I are not in same phase and they are out of phase. What such things are called as? They are called as out of phase. So such diagrams in which the alternating quantities are having some phase difference are called as out of phase. Understood this? So here at every phase, means this is one phase, this is one phase, this is one phase, like that. At every phase you are having some difference. So here the phase difference of T by 4 exists in this whole propagation of the wave which are moving in the same period. Understood? So this is about out of phase and in phase. So these things, when you think of this phase difference, you are coming in contact with the two important words. You are using two important terms. I will name them as lag and lead. Means when you think of phase difference, means in the first one in phase there was no any phase difference, no question of anything. But here when you get out of phase, you are using two important terms, that is lag and lead. So what will be the dictionary meaning of lag? Lagging means what? Going back of something. Means you are going with respect to something. You are following something. You are not going your own. You are following something. Lead means you are in the lead. You are front of everything and everybody is following you. So these two terms of lag and lead I am using in this explanation of phase difference. How? See here. At this point, the A is at 0, means the alternating voltage is at 0, and B means alternating current has already reached the point T by 4, means the current is leading, the current is in lead, it is already at T by 4, means it is already covered some distance, but A is still at 0. Okay, so when again current moves further, it reaches T by 2. So at that time voltage reaches T by 4, means current is always moving further. Current is always moving further and voltage is just following it. That's why we can say that current is leading and voltage is lagging behind the current. Means current is following it. Current cannot be the same position at the voltage at any time, because it will always move the distance T by 4 further. That's why here in this diagram current is leading the voltage. Or you can also say the statement as voltage is lagging behind the current with the phase difference T by 4. Understood? So here what's happening here? The current is leading the voltage with the phase difference T by 4, or also you can say it as voltage is lagging behind the current with the phase difference T/4. These explanations, or you can say these last statements, are very important when you think of the next coming things. Means next we are connecting the alternating current to different electrical components. So at that time, such statements of lagging and leading holds very important rule, or the rule of phase difference is very important at that time. That's why you get them clear now only. Okay, so this is about the concept of phase difference. Okay, so moving further. So you already know that alternating current or alternating voltage is nothing but one factor which is changing with respect to time, and that current is not constant, it is changing with respect to time. And you know how we will represent a source which is supplying a alternating current to us. So this is the symbol of AC source. What is this? This is one AC source. So whenever you are using this AC source in any electrical network, that network becomes AC network, or you can say AC circuit. So in any electrical circuit or in any electrical network, you are using this source of power supply. Means such current you are flowing in that network, such networks are said to be AC network or AC circuits. So here I am using AC source in the every electrical network so that I can change some hypothesis like, see here, the first what I am using, AC source connected to a resistor and AC source connected to a inductor and AC source connected to a capacitor. Means you know these three components, right? This is resistor, inductor, capacitor. These are the simple electrical components you are using in your electrical circuits. About resistor we have studied thoroughly in the 4th chapter, isn't it? So this is one electrical component which is represented like this. Yes, you are familiar with it already. You know what its function is. It opposes the flow of current in the circuit. So this is what? Resistor. Next, inductor is also one electrical component. I don't know if you know about it or not. So this is like this. This is the electrical component which is called as inductor, and the capacitor will be like this. Okay, so what is the function of inductor and capacitor? So this inductor is used in the electrical network. It opposes the flow of change in current. It opposes change, means you know the law of Faraday's laws, na? EMI, electromagnetic induction. In that you know the Faraday's laws. Faraday's laws, first law says what? Whenever in an electrical conductor, means a current carrying conductor, current is flowing in that current carrying conductor with respect to the magnetic flux. So the change in magnetic flux linked with this coil produces an EMF in this circuit. So the Faraday's first law states that change in magnetic flux produces EMF in the circuit. So here, whenever in an current carrying coil or conductor, current is flowing, around that magnetic field is produced. So around that conductor, magnetic field is produced in a circular manner, and that magnetic flux is continuously changing. So that magnetic flux produces an EMF in the circuit. So EMF is produced means what? Voltage is induced. So there we will use the word induced. So in this circuit, in this conductor, already current is there, and current is producing the magnetic field, and that magnetic field is continuously changing, and because of that changing magnetic field EMF is produced, or also you can say voltage is induced in the circuit. So this voltage induced is there, means induced voltage is there. Let I will call it as VI. This induced voltage has a tendency to oppose the change of current in this circuit. This induced voltage is there now. This induced voltage can oppose the change in current in this circuit, and that phenomena is called as inductance. Understood? The induced voltage has a tendency of opposing the change in current in this conductor, and that phenomena is called as inductance, and the device or the electrical component which will possess the phenomena of inductance is called as inductor. So this is inductor. Okay, and next is capacitor. Capacitor you are familiar with it, means you are studying electrical charges, electrical capacitance, everything. So electrical capacitor is nothing but it is also one electrical component. It stores the charges, means this is used to store the charges in the circuit. So going with one by one, I will first deal with the alternating source or alternating current source, AC source connected to a resistor. So what I am doing here, I am considering one AC source. So this AC source is connected to a resistor of resistance R. That is very much familiar to you. Resistance and resistor are known to you. So I am connecting one AC source. We are connecting this AC source to one resistor of resistance R. Okay, so such a circuit in which AC source is connected to resistor is called as a resistive circuit. Such a source in which AC source is connected to a resistor is called as a resistive circuit. So in this resistive circuit, what's going to happen? I am studying it now. Okay, we are studying it under alternating source or alternating current source connected to a resistor. So in a circuit we are using AC source and we are connecting it to resistor of resistance R, and we are calling that to resistive circuit. So what happens exactly in this resistive circuit we have to study. Okay, so in this resistive circuit you have one AC source. Let the voltage of that AC source be V is equal to V0 sin omega t. This you know already. In the first class only I told you alternating voltage and alternating currents are represented by these equations. V is equal to V0 sin omega t, I is equal to I0 sin omega t. So here V0 is instantaneous voltage, omega is angular frequency, and t is time period. So in this AC source we are considering one alternating voltage, and that be V is equal to V0 sin omega t. Okay, so with respect to Ohm's law in this circuit, what happens with respect to Ohm's law? V is equal to I by R. This you know already. So what I will be? I is equal to V by R. Let's call this as equation number 1. So by Ohm's law, you know I is equal to V divided by R. So this equation, in this expression, use the value of V. So what happens? V0 sin omega t divided by R. Yes or no? Means from the equation 1 we have used the value of V and substituted for V0 sin omega t divided by R. Okay, so if I is equal to V by R, what V0 by R can be? Means here V is instantaneous, V is voltage, normal voltage, and I is current. Here V0 is instantaneous voltage. So when you think of V by R, it can be I. So when you think of V0 by R, can I write it as I0? Yes or no? Why can't I? I can write it like this, na? Instantaneous current and instantaneous voltage. So V0 by R. V0 by R in this expression are replaced by I0. So what the expression can become? I is equal to I0 sin omega t. Call this as equation number 2. Now compare equation 1 and 2. V is equal to V0 sin omega t. I is equal to I0 sin omega t. They are simultaneous equations. There is no any change between them. So how can I represent those two equations? Can I represent them like this? Means let this be V0 and let this be I0. So they are in same phase. Sin omega t, sin omega t. There is no any omega t minus pi by 2, omega t plus pi by 2. They are same, omega t. So they are in phase. What is the meaning of in phase? You know it already. So here there is no any phase difference existed between voltage and current. Alternating voltage and alternating current when you are studying AC under a resistor. So what can I conclude here? What can be my concluding statement here? In the resistive circuit, the alternating current and alternating voltage are in phase. There is no any phase difference existed between alternating current and alternating voltage in a resistive circuit. So this is about the first thing. First thing what I have done, I have connected alternating current source to a resistor and I called that as resistive circuit. So in the resistive circuit, I have derived the alternating current and alternating voltage are in phase with each other. There is no any phase difference between I and V. Next, the same with respect to inductor we have to study. Alternating source to a inductor. What will be the inductor? I told you. So the same, what we have to do? We have to connect one AC source to what? To inductor. And as you have considered the resistor of the resistance R, here it's this inductance I will consider L. This is the component inductor and its inductance is L. So such circuit is called as what? Inductive circuit. This is called as inductive circuit. In the previous one we have connected resistor of resistance R and called it as a resistive circuit. But here it is inductor of inductance L and it is called as inductive circuit. So what will be the inductive circuit? When an AC source is connected to inductor of inductance L, it is said to be inductive circuit. So here the things will vary. The things will become different for some extent. So what it can be here? We have to start it similarly. What we have done? V is equal to V0 sin omega t, which is already given. Means in this circuit the alternating voltage is V is equal to V0 sin omega t. And I told you this inductor is nothing but what? I told you it opposes the change in current. Means EMF is produced and that EMF opposes the change in current. Okay. So here one EMF is produced and that EMF I will write as minus L into di by dt, because L is the inductance, I is the change in current. So EMF produced in this circuit I will write as minus L into di by dt. Okay. So here in this circuit we don't have any potential drop. Means we already have the electrical voltage, means alternating voltage, and the EMF and the inductance. So the potential, the strength of this circuit is not going down. It is not dropping. So here there is no any potential drop. That's why I can write it like V plus minus L into di by dt is equal to 0. Why? Because in this circuit there is no any potential drop. Okay. So V plus minus L into di by dt is equal to 0. Now start the mathematical parts. L di by dt. Can I write it like this? V is equal to L into di by dt. So what will be the di by dt? V divided by L. Di by dt is V divided by L. What will be di? So di will be V by L into dt. Understood? From here I got this. Di is equal to V by L into dt. Now from the equation 1, can you substitute the value of V in this? Yes, that is V0 sin omega t. So what will be my di? I will create some space here for the derivation. So my di will be V0 sin omega t whole divided by L into dt. So can I write it as V0 by L sin omega t dt? And I am just adjusting the terms with respect to the parameters. Okay. So now this equation we have to integrate this equation. Okay. Now integrate this equation. V0 and L are constant. Leave them as it is. Integrate. So this is already di. You will get I here. V0 and L are constant. Take them outside. Okay. So integration of sine theta. Integration of sine theta. What it will be? It will be minus cos theta. Minus cos omega t divided by omega. Because we don't have only theta here, omega t. With respect to t, you are doing the integration and omega. I don't think this I have to explain much. You are perfect in the maths, omega. Okay. So this is as it is. Okay. Now I is equal to V0 by L omega minus cos omega t. Okay. This is like minus cos theta. So can I write minus cos theta as sin pi by 2 minus theta? This is by the trigonometric relations. Minus cos theta can be written as sin into pi by 2 minus theta. Like, and continuing the derivation, I is equal to V0 by L omega sin pi by 2 minus theta, means sin pi by 2 minus omega t. It is sin theta minus pi by 2. Sin theta minus pi by 2, hence it is sin omega t minus pi by 2. It's better if you go on writing the things. Just go on recording the things. V0 by L omega as it is minus cos omega t. I have changed as minus omega t, sin omega t minus pi by 2. Okay. So here in this equation, you know the first equation. First equation is V is equal to V0 sin omega t. And as you know, we have to form the equation number 2 and we have to compare them. Okay, now this I V0 by L omega is there, na? Can I take it as I0? Means I is equal to V by R, like that. I is equal to V by L omega and I0 is equal to V0 by L omega. So what this equation can become? I is equal to I0 sin omega t minus pi by 2. So this is equation number 2. So this is all the derivation I am doing. So up to here, equation number 2, what I have done, I will tell you once again. So in this equation, in this circuit, I am using one AC source and I am connecting it to one inductor of inductance L, and such circuit is said to be inductive circuit. And in this inductive circuit, we know the alternating voltage V0 sin omega t, and we are considering the EMF in this. That EMF is minus N into di by dt, and by that we are using di is equal to V by L into dt. Just adjusting the terms, substituting the value of V from the equation 1 and integrating this equation. So after integration, you are getting like this, and minus cos omega t, and replacing sin omega t minus pi by 2 by the trigonometric relations, and hence I am getting I is equal to I naught sin omega t minus pi by 2. Now the important thing occurs. First equation and second equation. Let me rub all these things to get a clear idea about phase difference in inductive circuit. So first equation was V is equal to V0 sin omega t, and second I naught sin omega t minus pi by 2. This was what my second equation. So now can you compare? V is equal to this, I is equal to this. Can you see some difference in this angles now? Sine of something means this is like sine theta. This is like sine theta minus pi by 2. Means which is greater and which is lower here? Can you think? Because sine theta is there here. Whole sine theta is there. But here from theta I am subtracting something. Means from omega t I am subtracting pi by 2. So hence this I becomes lower one and this becomes greater one. So can I show them like this? Means V is as it is. So when V is at 0, I is at pi by 2, means lower, minus. So it goes like this. It goes like this. Means like this it comes. I told you the out of phase at the explanation of phase difference only. So this I is lagging. Means if I will be here, it will be plus pi by 2. It will be, if it will be here, it will be plus pi by 2. But hence it is minus pi by 2. It comes down. Means here I is said to be lagging. Means and V is said to be leading. So V is further. V reaches the equilibrium points earlier than I, and I just following V. So here I is lagging V, or also you can say V is leading I with the phase difference pi by 2. So this is the importance of the concept of phase difference. So here in this inductive circuit, the current is lagging voltage by the phase difference pi by 2, or also you can say voltage is leading current by the radian pi by 2. So this is the conclusive statement of inductive circuit. Okay, so this is all about inductor and resistor. So one more thing I'll tell you. Inductive reactance. Inductive reactance XL. Means as I told you, inductor is nothing but it opposes the change in current in the circuit. So here inductive reactance is the effective opposition offered by an inductor. Inductive reactance is the effective opposition offered by an inductor in a current carrying circuit. Understood? Inductive reactance is nothing but what? An effective opposition offered by the inductor to the change in current in a circuit. It is one effective opposition offered by the inductor to the change of current in a circuit, and I will represent it as XL, that is L into omega. So this XL is called as inductive reactance and its SI unit is ohm. So this is all about alternating source connected to a inductor. Okay. So next we are going to study about alternating source connected to a capacitor, and with respect to that we will get capacitive reactance that we will study in the next class. Thank you. Take care.